Alright, so what we want to do today is show you how I set up my user-defined data types and add-on instructions. Really kind of helps organize your project, keep it clean and neat, especially if you're going to do the same thing over and over again. We're going to start a new project. We're going to call it test data types. I'm going to go with 32. There's several different ways to do this. It's going to come down to personal preference. And always keep in mind the people that are going to interact with the program after we're done designing and commissioning it, to make it easy to troubleshoot, because it's important that whoever is going to follow us is able to quickly find what they're looking for, that the program makes sense logically, and for things to be consistent. So when they see something in one place, they know how to match it up throughout the program. And so first thing we're going to do is we're going to start setting up some data types. We're going to add a new data type, and we're going to call this motors. Typically most applications we run into have motors. So we'll call that one motors. And some basic things. We're going to need a start, push button, and you can add a description if you label it right and things make sense. The descriptions don't have to be too long. Too much reading sometimes is not good. It's counterproductive. We're going to need to stop, push button, which is going to be a bullet. We're going to need a request when we request the pump to come on, our motors to come on. It's going to be a boolean. Many times you're going to need a permissive. We're going to have a fault. We're going to have a coil. We're going to have a status that is running. And some people capitalize the whole thing. Some people use all lowercase. The main thing is to keep it consistent. Whatever you start with, try to maintain that same format. Status word. mainly for indication of if it's faulted, which fault, change colors of the alarm, so we'll know what status it is, keep up with what problem it is, if it's running, if it's off. So that's going to be integer. We might have a thermal guard, which is the mister inside the motor. If it gets too hot, it opens up. And start, stop, coil, running, fault, failed. If it failed to start, we're going to set up a block for that. Let's see what else we can do. Might have some hand valves, third pumps. Hand valve A. Valve B. And we can come back in here later, add some more things as we find it in the program. As we start doing things in the program, we can go back and add to it. So right now I'm going to leave this alone. I think we got everything we want to start with. So now I'm going to go in here and we're going to interact with an HMI. So I'm going to start the HMI data type. And what this is going to do is allow us to be clean throughout the program. So we're going to need a start, push button. As we start laying it out, you'll see why we add some things, where we add them. Stop, push button. It'd be nice if they automatically defaulted to the last data type you used in autofill, but we want a reset button. I think stop there. That should get us started. And typically what I'll do is I'll set up a buffer input and buffer output to where the cards are directly mapped to what input they are going to in the program. Try to keep real hard inputs and outputs out of the logic. And it just makes it so much easier to troubleshoot when you can see multiple inputs, multiple outputs at one time. So right now, we're just going to set it up in the main routine. Show you what I mean. Throw a few contacts in. Set it up. Alright, so now we can either tap on that and create our tag, or we can go ahead and go to controller tags and go to edit. And we're gonna say, okay, this is motor. It's gonna be motor 1. And the data type is going to be the one we just created, which is motors. One more thing I want to do real quick is go ahead and go back to the motor data type. We're going to add one more in, and it's going to be HMI. And that data type is going to be the one we set up for HMI. So now the ones that we created for the HMI are going to show up under this main motor data type. So it's just a data type embedded inside of a data type. Now we can go back here. And the reason why I didn't call it motor 1 is so I can copy it and paste. So now my motor data type has my coil, fault, and then it's also got my HMI. And you can set up several more, embed several more inside this one data type. And it just helps your program look clean. If the technician's working on the machine, he knows, okay, everything that has to do with motor 1 is going to start out with motor 1. Start push button. And now we can go to motor 1 dot HMI dot start push button. And we go motor 1 dot running. And then we can do the stop buttons. So you can do that, or you can drag this up and just change the start to stop. Advantage to make sure all your tags are the same. One good thing with the data type is they are all the same. So most of the time you only have to change a few things and they all match up. And then of course our coil. And that's it. That's motor 1's going to start. It's going to run until you push the stop button. Most of the time you'll have a permissive, which we use, so this motor can only run if certain conditions are true. We got our permissive, and we can monitor e-stops, hand valves. So we want to make sure that we're getting a signal from the hand valve. So motor dot hand valve A. So as long as the hand valve's closed, and I can copy that, drag that, change the A to a B. So our hand valves are good. Our T-guard. As long as those are good, you can add in whatever needs to be added to set a condition for your motor to run.